Hi, my name is David, and together with my teammates Varun and Rosalind, we examined the beer and breweries data sets in the United States. So first, we examined the number of breweries in each state, and we found that there is at least one brewery in each state. The three states with the most breweries were Michigan, California, and Colorado, each with 30 plus breweries each. Only 50% of states had 7 or less breweries, and 20% of states had 20 or more breweries. This heat map also examines these facts. Again, we see that California, Colorado, and Michigan each have 30 or more breweries, and that at least one brewery is present in each state. Next, we examined the number of beer produced per brewery in each state. And we found that Washington, D.C. has the most number of beer produced per brewery at 8, and Delaware has the least number of beer produced per brewery at 1. Next, we examined the median alcohol by volume of beer per state and the median international bitterness unit of beer per state. We found that Kentucky and DC were tied with the maximum median alcohol by volume at 0.0625, and that Maine had the highest median IBU for all states. We also decided to exclude all missing values for ABV and IBU. Next, we examined the maximum alcohol, the beer with the maximum ABV and the beer with the maximum IBU. We found that the beer with the maximum ABV was a quadruple style brewed in Colorado, and then the beer with the maximum IBU was an IPA style brewed in Oregon. Next, we examined the distribution of ABV, and with the histogram and with the box plot. And we found that the distribution is right skewed, meaning that the mean is greater than the median, and that the mean was found to be 0.0598. The minimum value that was found in the data set was 0.001, and the highest was 0.128. The IQR, or interquartile range, was between 0.05 and 0.068. Next, we tried to find a relationship between ABV and IBU. We found that there seems to be a positive correlation between the two, but as ABV and IBU increase, there seems to be a weaker correlation between the two. So next, we wanted to be able to predict whether or not a beer was an ale or an IPA based on solely ABV and IBU values. So doing this, we used KNN. So to do so, we split our data set into a training set and a test set. The training set consisted of 70% of our original data set, and our test set consisted of 30% of our original data set. The KNN model took on the training set, and for each observation, the test set, the model was used to find the closest point and determine the classification of the observation based on the points around it. So for example, if this circle dot is a test set, is an observation in the test set, we use the three surrounding points to determine whether or not we should classify the beer as an IPA or an ale. So clearly in this case, it would be an IPA. Again, if we circled this next red dot, we would look at the surroundings and find that the closest points, neighboring points, would have mostly an ale classification, and thus this test point will be classified as an ale. So the graph shows, this is the graph that shows the actual classifications of the beers as either ale or IPA. And we found that the accuracy of our KNN model was 88% effective with a sensitivity of 0.8835 and a specificity of 0.8839. So this graph is a graph of our predicted classifications using KNN. We used a K value of 3, and that this is the value that maximized our accuracy, our sensitivity, and specificity. If you have any questions, please feel free to contact us at varunji@smu.edu or Rosalind or myself at our emails. Thank you.